for corresponding parts of congruent triangles are congruent. So when we do these proofs, these are CPCTC proofs, we first need to prove the triangles are congruent, and then we can use CPCTC. Okay, so if we're still going to use side, 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 angle, side, or angle, side, angle, we're going to pretend it's a proof just like the ones we just did. But then once we get there, we can say, oh, these angles are the same, or these sides then must be congruent. Now, this is a little bit of a trickier diagram. What we have here is one triangle. That's red triangle, overlapping this triangle here, blue triangle. So let's see what we're given. We're given that OV is congruent to ER, given. So that's here, OV and ER, that those lengths are the same. So again, red triangle, overlapping blue triangle. And then I'm given that OE, which is this long length, that this OE is congruent to RV, which is again that long slanted length on the other one, given. So right now, comparing red and blue triangle, this side and this side, this side and this side are the same. Now, this way the look for looks here is different. Do you see how they both have this third side? So that's reflexive property, but it doesn't really look quite the same as the other ones we've seen. The other ones, it's almost like this red one's flipped over and they shared the side in the middle. Okay, right now they're just overlapping, but they both have, blue triangle has side VE and red triangle has side VE. So this is a reflexive, right? Say VE is congruent to VE by reflexive property. They share that side. So now I have all three sides match, which means I can say my triangles are congruent. So order matters here. If I go OVE, that would be congruent to triangle REV by side, side, side. 1, 2, 3. And just like when we did the first page of our quiz review, if the triangles are congruent, then all of the corresponding angles and all of the matching sides are. So if these triangles are congruent, can I say that O and R are congruent? Yes, because they're in the same spot in my statement. Corresponding parts of congruent triangles are congruent. That's the CPCTC. It's just following up, saying, hey, these triangles are congruent, therefore those angles are too. And I could have said other angles as well. That one happened to ask for O and R. It's really just a follow-up. So let's just look at one more because the homework's going to kind of force us to do lots of proofs. Let's look at 4 because I do like talking about perpendicular. Look at all those steps. 4 out of 10 though are givens. So a lot of the givens on 4 have what I call follow-ups. So first, let me write the first 2 givens. So BR is perpendicular to RE, given. BR is perpendicular to RE. That means that it's creating a right angle here. Okay, so what perpendicular means. BR is perpendicular to RE. So then what I can say is that angle R is a right angle. That's the definition of perpendicular. And that's all I can say on this particular perpendicular one because I got to piece it together with the next given. So these are perpendicular, so angle R is a right angle, definition of perpendicular. It also tells me that over here that FE is perpendicular to this line. So if FE is perpendicular to RE, given, then it'd be creating a right angle here. Angle E is a right angle, definition of perpendicular. Now on the proof bank that I was just talking about, we wrote perpendicular has 2 follow-ups. Well, for both of those, I only did 1 follow-up so far. I haven't gotten to the second one. So with perpendicular, I say which angles are right angles. Okay, so now I've done that. Now I can say those angles then are congruent because all right angles are congruent to each other. Okay, they're all 90-degree angles. So since I knew that this was perpendicular here and that this was perpendicular here, creating these right angles, I can say that angle R is congruent to angle E because all right angles are congruent to each other. Phew. Okay, so those are my first 2 givens. Now I know that angle 1 is congruent to angle 2, so I'll mark that given. Nothing to follow up there. Done with that given. And then I also know that I, which is here, is the midpoint of RE given. Midpoint needs a follow-up. So if I is the midpoint of RE, what does that mean is true? What 2 segments then are the same? I is the midpoint of RE. Which ones?
RE.
R to I would be the same as E to I. So if it's the midpoint, then it means it's cutting this segment in half, that this length would be the same as this length. And RI would be congruent to EI. That's the definition of midpoint. So here's my follow-up to midpoint. Now, I can say these triangles are congruent by which case? Looking at just one triangle. I have which one?
Angle, side, angle.
Angle, side, angle. So I can say triangle BRI is congruent to triangle FEI by angle, side, angle. Now here's the tricky piece. So here's congruent angles, here's congruent angles, here's congruent sides. So I have to scan through all of those steps to know where my angle, side, angle is, and then list those. So angle in step 5, side is in step 8, angle in step 6. And now if my triangles are congruent, then all of its corresponding parts are congruent. So I would be allowed to say that this segment BI must be congruent to this segment FI, because the triangles are congruent. So BI must be congruent to FI by CPCTC. It's just following that congruency statement with an extra kind of layer there. Okay, let's look at the homework. So homework 28, more of these proofs. These I feel like are the first 3 at least are pretty direct proofs. Okay, but again, the way you get better at these is doing more proofs. Like you can't just stare at the paper and have it absorb. You gotta kind of like a flow, like as I write this step, I'm going to follow it with the next step, or I know to look for these things, and you kind of get used to, just like you get used to writing a letter, you get used to writing the proof, and the more you do that are similar, the better you get at it. So first given is that C is the midpoint of AD given. C is the midpoint of AD. Let me just highlight AD. Anytime I write midpoint or bisect, I follow it up. So if C is the midpoint of AD, what then is congruent?
AC and CD.
AC and CD, yeah, but it's cutting this into 2 equal parts. So I follow that by saying AC then must be congruent to CD because that is the definition of midpoint. And then my next given is that C is the midpoint of EB. Oops, I wrote a D. EB. Let me highlight that segment. Here's EB. If C is the midpoint of that segment, then what must be true? Follow it.
EC is congruent to CB.
EC is congruent to CB by definition of midpoint. Let me mark that. I breathed in funny. Okay, there are my givens. Now I go to look fors. What else do we see here? Going just to the diagram. Vertical angles. We're always looking for vertical and reflexive. Right here, I have vertical angles. So I know that this angle is the same as this angle. Now I can't use angle C because I got to talk about which side I'm talking about. I got to use other letters. So I could say ACB and DCE, just so I know that I'm talking this angle and that angle, since they're both angle C. So going to look for is I know angle ACB is congruent to angle DCE, vertical angles. Okay, so like this is the procedure. I've gone through the givens, I've done any follow-ups to those givens, and I've marked things. Once I get through my givens, I go to look fors, reflexive property, vertical angles, whatever, shared sides that are like that last one that are on the bottom, still reflexive. Once I've done the givens and the look fors, I'm looking for a case. So either side, 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 angle, side, or angle, side, angle. Which case do I have here? And I will look at one triangle to figure that out. Side, angle, side. Now for the CPCTC proofs, we need to figure out the order because order matters here because that's not given to me in my proofs. So I'm going to say triangle ACB congruent to triangle. So AC is this yellow strip. So I'm going to go DCE by side, angle, side. My side, so and then here's the next tricky piece, right? So my sides are here, 2 and 4. Sometimes it's nice to mark them as you go. So then you're just looking at the ones like, I could have been like, oh, I'm going to put a little star by that because that was a piece I marked in my diagram. So then I'm limited to where I'm looking. And then here's my angle is in step 5. So that should go in the middle. Now let's look at what it wanted us to prove. It wanted us to prove that A is congruent to D then, and they're corresponding angles, so that works. Angle A congruent to angle D, CPCTC. Okay, just following that congruency statement with one other piece. Okay, flip this over. We'll do 2 and 3, I'll leave the challenge one. So it says given NO is congruent to PQ. That's given. NO, PQ. Angle ONQ is congruent to angle PQN. Given, so that one we need to think through. ONQ is here. PQN is here. Okay, those are my givens. They don't have any follow-ups, they're just statements. I've marked it. When I'm done my givens, I go to look fors. What do I have here?
Reflexive.
I have reflexive property. So I can say that NQ is congruent to NQ by reflexive. I've done my givens and my look fors. I should be ready to say that they are congruent. I look at just one of these 2 triangles and see that I have a side, an angle, and a side. I have a side, an angle, and a side. So I know that my reason is going to be side, angle, side. And now comes the tricky piece, matching up corresponding parts. So if I go ONQ, triangle ONQ would be congruent to, what do you think? So I went O to N, so I went along this length that's marked.
PQN.
PQN, yeah. PQN. By side, angle, side, and look, they're in order, side, angle, side. So 1, 2, 3. And it wants us to say that NP, which are the outer letters here, is congruent to OQ, outer letters there, so that seems to check out. NP is congruent to OQ by CPCTC. So in my proofs, I know that I'm using CPCTC if it's ending with it proving an angle or sides congruent. I know that I'm just stopping here if it's ending with triangles congruent, and so then I don't need CPCTC. Okay, so if I get to a proof on the end of unit assessment and I see, oh, it wants me to prove angles, I should immediately know that this proof will end with CPCTC. That I'll prove the triangles congruent and then I'll write that last line. Okay, now this one's super quick. IJ congruent to KL. IJ, KL, IK to JL, IK to JL. There are my givens. What's my look for here?
AJ is congruent to KJ.
Yep, little reflexive property. Mark it. And these are the easiest proofs. Triangles are congruent by what?
Side, side, side.
Side, 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 which is in 1, 2, and 3. I just have to think about order. So if I go, let's go KIJ, and you could go in a different order than me. Like if your homework's in a different order, as long as like K and whatever it's matching up with is in the same spot, you're good. So KIJ would go to JLK. By side, side, side. And so then I and L, those angles are in the same spot, so we're good. Angle I congruent to angle L, CPCTC. Okay, so it's just an extra step there at the end. Okay. So now we're going to kind of transition over. I would love to give you some time to try some more CPCTC proofs. Let's do notes first, and we'll see how much time we have left. So we're going to look at notes number 4 today, which is actually not anything new. We've done notes number 4 before. We talked about it with the rectangles. We're just adding it into this unit as well, but it's not new. Okay, did we find notes number 4? So it would be in our other packet. If not, I have some new packets too. So we've already talked about this. We talked about it in our triangles, angle side theorem. So the angle side theorem says if my angles are the same, or sorry, if my sides are the same, then my angles are the same. We used it with our rectangles because all the diagonals were congruent. Or I could go the other way. If my angles are the same, then I know my sides are congruent. So it goes both ways. And so what we're talking about is an isosceles triangle for this, that if I have two sides the same, then the angles across from those sides are also congruent. If I knew this was an isosceles triangle, then I also know those angles are the same. And what's the nice thing about knowing that these angles are the same? That I can find the third angle because the triangle adds up to 180. Okay, so it allows me to solve many different ways. I'm just going to rewrite it with some more words. If two sides are congruent, we're the same. and two angles are congruent. And vice versa, the converse is also true. So what do you think that means then for the equilateral triangle? So what if all of my sides are the same? What do you think is true about my angles? If it's all sides are the same, all my angles are the same. So it follows suit where, oh, two sides are the same, those two angles would be the same. If it's equilateral and all of my sides are congruent, then all angles are congruent. And so what does that mean? Actually, it's more than just knowing the angles are congruent. If it's a triangle, then how many degrees would each angle be? They're all the same. We know what a triangle has to total. If I broke it up evenly, what would each angle have to be? 60 degrees, yeah. So beyond that, I even know if it's equilateral, I know that all of these angles, not only are they all the same, but they're all 60-degree angles. Okay. So we can use that to solve a little algebra type problem. Okay, where, let me kind of color code here. I know that this is 80. If these sides are the same, then the angles, it's the base angles, it's angles across from those sides. So given these sides, I know these angles are the same. So I have to use a little logic here. If I have 80 here, then I know between the two, I have 100 degrees left. So if I know they're the same angle, then what must each angle be? 50 degrees. So I go, okay, this is 50 and this is 50, or x equals 50. Then I get here and I use vertical angles. So I know that's 50. And now I again have an isosceles triangle here. Now if these sides are the same, then these angles are the same, which means this is 50. And now I have to find y. What would y be? 80, because the triangle has to total 180. Okay. Where it gets tricky is identifying this. Students really have a hard time with this. What type of triangle is that right there? Equilateral. So it doesn't give me any values. Like here it gave me 80. It doesn't give me anything here. That's because it's giving me an equilateral triangle. So that means all of those angles must be 60. So I go, well, that's 60, that's 60, that's 60, or y is 60. Now I can't go from here to this angle. I don't know what that is, but I can jump here. This is never going to go away. Okay, the whole idea that if I have a line, oops, I missed a letter there, or a linear pair, it has to total 180. So if this is 60, then this angle must be how many degrees? 120, good. Okay, so now I know that angle. And now if sides, then angles. Okay, so I got to divide the rest of the angle measurement within that blue triangle evenly. What must each angle be? 30. Yeah, so I have 120. That leaves me with 60 degrees in this triangle, breaking it up 30 and 30, because I know it has to be broken up evenly. Sometimes students have a hard time knowing what two angles are the same. So you got to kind of go across from those sides, which in a triangle like this is a little hard to see. Or you can think about it as the side that's not marked. That helps students sometimes. So here's the marked side. The sides that's not marked, those two angles connected to that, those are the two that are the same. So like in this triangle, that's the unmarked side. So the angles attached to that side are the ones that are the same. Our last one goes the other way because we want to remember the converse is true. So if I know the angles are the same, then I know the sides are the same. Okay, if angles, then sides, it goes both ways. So 5x plus 7 has to equal 42. Or 5x equals 35. And x equals 7. Okay, it goes both ways. This one's going the other way. If angles and sides. Okay. Now that's the notation that we use in proofs, this right here. Okay, this is what we use for proofs. Use in proofs. Okay, we use that notation if it comes up. So we're going to do just one more proof, and then I'll let you have some work time to try some proofs on your own. And I'm going to do the bottom one here. I like this one a lot better. Okay, so we're not going to go back to that one ever. I'm going to do this proof. And so create your little table. And we can see here that it's ending in congruent triangles. So we're not going to land at CPCTC. We're going to stop the proof at either side, 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 side angle, side, or angle, side angle. Okay. So first given is that MD is congruent to MA, given MD, MA. N is the midpoint of DA, given. N is the mid, well, actually, I'll do it after. So what is my follow-up to N is the midpoint of DA?
DN is congruent to NA.
DN is congruent to NA. Now there's two ways I could do this proof. I guess I could use reflexive property. We're not going to here. N is congruent to NA. Definition of midpoint. So I should have done it right after the first step. It would have been a little clearer. We have two triangles, but we also have this big triangle that they create. So on that first step, when I said MD and MA are congruent, well, if these sides are congruent, then those angles are congruent. Okay, so it's just kind of another way to get there. I could have also used reflexive property here, but when I wrote this step, I should have followed it right away because it would have been a little more clear. That's giving me a big isosceles triangle. And if I have an isosceles triangle, then I have angles that are congruent. So this is kind of a follow-up to step one, where I can say, well, then angle D is congruent to angle A, because if the sides are the same, then the base angles are the same. And now that we did that, we can say those triangles are congruent by another way. MDA congruent to MAN, that gave us side angle side. Side angle side, okay? But I could have also used side, side, side there, and that would be fine. Both proofs would be acceptable proofs. And just kind of another way to find congruent angles as I'm setting it up. Okay, with the little time that we have left, I want to talk about, and obviously I'll